Welcome to The Explainer. Today we're breaking down the fundamental principles of the gyroscope to get you ready for any exam. Ever wondered how a spinning top seems to defy gravity? Or how a bicycle stays so stable? Well, the answer is the gyroscope, and we're about to figure out exactly how it works.
Okay, so here's our game plan. We'll start with the basics, what is a gyroscope? Then we'll get into its two main properties, which are kind of like superpowers, rigidity and precession. After that, we'll see how they're used in the real world, and we'll wrap up with a quick review to make sure everything sticks.
I mean, it's a great question, right? This seemingly simple toy is actually a perfect demonstration of a really powerful physics principle. It's the same magic that keeps everything from bicycles to airplanes stable. It's all about that gyroscopic effect.
So, let's put a formal name to that spinning top effect. We're going to see what makes a true gyroscope, the kind you'd find in a high-tech navigation system.
Okay, here's the most important part of that definition. It's not just about spinning, it's about being free to move. That mounting system, the part that lets its axis point anywhere, is the whole secret to its amazing abilities.
So, how does it get that freedom? Well, take a look at this. See those rings? They're called gimbals. They let that spinning wheel in the middle, that's the rotor, pivot in any direction. This means no matter how you tilt the outer frame, that rotor can keep pointing in the exact same direction. It's pretty clever.
All right, now for its first major property. The official name is rigidity in space, but I just like to think of it as the stubbornness of a spinning wheel. It's this incredible ability to resist any changes to its orientation.
Think of it like this. The gyro wants to keep pointing in the exact same direction it started. So if you're on a plane that's banking and turning, a gyroscope inside will just keep pointing true, providing a perfectly stable reference point. That's absolutely crucial for navigation. So what makes one gyro more stubborn than another? Well, our source material says it comes down to three things: how heavy the rotor is, how that weight is spread out, and of course, how fast it's spinning. The heavier, faster, and more spread out the weight, the more stable it becomes. And this right here is a perfect illustration of maybe the most important factor of the three. Look at rotor C on the right. By concentrating the weight out at the rim, it becomes way more rigid than the one on the left, even if they both weigh exactly the same. It's a really smart design trick. Okay, let's move on to its second, and honestly, more counterintuitive property. This is all about what happens when you actually try to force a gyro to change direction. It doesn't react the way you think it would.
And this is the weird part. If you push on a spinning gyroscope, it doesn't move in the direction you pushed it. No, it moves at a right angle. That's 90 degrees to the force. This is called precession, and it's a little bit of a mind bender.
This right here is the golden rule of precession from our source text, and it's essential for any exam. The gyro responds by moving its axes at a right angle to the applied force. If you remember one thing about precession, make it this.
This image shows it perfectly. Gravity is pulling down on the gyro, right? So you'd think it would just fall over. But because it's spinning, that downward force gets turned into a sideways movement. It precesses instead of falling. Pretty cool, huh?
So we know it moves 90 degrees away, but which way? Left, right, up, down? Luckily, there's a handy trick to predict this movement, and it's called the right-hand rule. Let's break it down.
Okay, first step. You got to find the direction of the spin itself. Just take your right hand and curl your fingers in the same direction the rotor is spinning. Your thumb will naturally point along the spin axis. That's it. That's your spin vector.
Now for the magic. Keep your thumb pointing along that spin axis. Then point your index finger in the direction of the force you're applying. Now look at your middle finger. It's pointing exactly where the gyro is going to precess. It's a foolproof way to figure it out every time.
So we have rigidity and precession. We know a gyro is stable, and we know how it reacts to being pushed. But how are these principles actually used in the real world?
Well, by restraining a gyro's movement just a little bit, we can use it to measure how fast something is turning. This is called a rate gyro, and it's a key function in things like aircraft instruments and navigation systems.
So here's how it works. When something like an airplane turns, that motion creates a force on the gyro. The gyro, as we know, will precess. And here's the brilliant part. The amount of that precession is directly proportional to how fast the plane is turning. A slow turn means a little precession. A fast turn means a lot. It makes for a super reliable sensor.
All right, we've covered a ton of ground. Now let's lock in all this knowledge with a quick recap and some practice questions that come straight from the source material. This will get you ready for that exam.
Ready? Here are the 5 key terms you absolutely have to know. A gyroscope is a freely mounted spinning rotor. Rigidity is its tendency to stay pointed in one direction. Precession is that weird movement at a right angle to a force. The rotor is the spinning wheel, and the gimbals are the rings that let it move freely. Got it? Good.
Okay, first question. What gyro property causes it to remain in a fixed position? I'll give you a second. The answer is rigidity. That's its stubbornness.
Next question. What factors determine how rigid a gyro is? Think back, we talked about 3 of them. The answer is the rotor's speed, its weight, and its shape, or how that weight is distributed.
All right, last one, and it's the big one. In what direction will a gyro precess when you push it? The answer is perpendicular, or 90 degrees, to the force you applied. If you can remember that single rule, you've totally nailed the most important principle of the gyroscope.